Hey there everyone, it's Riley again, and this time I'm going to talk about concrete and the need to be more sustainable. So according to the International Energy Agency, or the IEA, as of 2018, construction as an industry accounts for 39% of all CO2 emissions. So with it being this high, there needs to be a paradigm shift towards making construction greener, and I believe concrete will make a good foundation to build off of, literally. See what I did there? In my informative speech, I talked about the history, uses, and components of concrete. I also threw out a number of 25 billion cubic yards placed every year. With concrete being the second most used material in the world, just behind water, the question has to be asked, is it harmful to the environment? Now, the immediate answer is yes, absolutely. However, strides are being made to make concrete greener. So what are those strides? So programs have been started to encourage more concrete recycling. You can substitute cement within the mix, which is the big CO2 contributor in concrete. And there are also greener forming practices. And with all of these, we can make concrete greener. So let's talk about concrete recycling. So what happens when a concrete structure is torn down? Where does that concrete waste go? Is it just thrown in a landfill and forgotten? Well, the answer to that question is quickly becoming a no. So, recycling used concrete and concrete reinforcement is becoming an increasingly common practice. Countries like Finland, the Netherlands, Japan, and many others require complete concrete recycling. According to an article published by the World Business Council for Sustainable Development, in 2009, the United States produced 317 million tons of construction and demolition waste. Of that number, 155 million tons were concrete waste. So 127 million tons of that waste were turned into recycled concrete, making the recovery rate a quality 82%. The process of recycling concrete starts with the removal of old concrete. So by blowing up a building, tearing up a road, anything like that. So once the concrete has been removed, it is taken to a recycling facility where any foreign substances such as metals, plastics, any other thing you can imagine that's in the concrete is taken out. Once these items have been separated from the concrete, it is crushed down to a specified size, washed and stockpiled for future use. So recycled concrete can be reused as aggregate for new concrete. Remember before we talked about the 5 different components of concrete: water, air, fine aggregate, coarse aggregate, cement. Coarse aggregate is what crushed concrete is usually. So it can also be used for road base, which helps support the asphalt, as well as structural fill, which helps, again, support a building, using those crushed pieces of concrete. So while using recycled concrete for aggregate or base prevents virgin aggregate from being mined, it does not provide an answer for the carbon emissions associated with the production of cement. So now we're going to talk about cement substitution. So while using recycled concrete for aggregate or base prevents virgin aggregate from being utilized, it does not provide an answer for the carbon emissions associated with the production of cement. So 1 ton of cement produces roughly 1 ton of carbon dioxide. Cement and overall cement production makes up 4 to 8% of all carbon emissions. The carbon dioxide is produced during the decarbonization of the limestone. So from the kiln fuel combustion and transportation, both around the cement facility and during distribution. So how do we reduce these emissions while still maintaining the production of concrete needed to support society? So the answer comes from 2 major carbon dioxide production processes, actually. So fly ash and slag cement provide 2 relatively sustainable answers to that question. Fly ash can be used to substitute up to 55% of the cement content in concrete while still maintaining the strength. Fly ash is a byproduct of coal burning. It consists of silicon dioxide, aluminum oxide, and iron oxide. Its pozzolanic nature, much like the volcanic ash that Vitruvius used for his Roman concrete, makes a cementitious compound when combined with calcium hydroxide, an alkali. Before it was discovered that fly ash was useful in concrete production, it was simply disposed of in landfills or ash ponds. Fly ash's unique properties improve the workability of concrete as well as its pumpability. It also lowers the heat of hydration for concrete, allowing it to cure quicker when concrete is mixed with it. So we also have slag cement. So slag cement is another sustainable substitute for cement in a concrete mix. Slag cement is produced during the smelting process of metals such as iron. Originally, it is part of the ore that is mined. However, during the smelting process, the ore is separated and goes on to become steel or other iron-based products. The remaining collection of silicates and impurities from the ore is then pulverized into a powder called granulated slag. It was found, like fly ash, that slag powder, when combined with water and Portland cement, created a cement that gained strength over longer periods of time, thus lowering the permeability of the concrete and increasing the durability. Most mix designs for structural or paving concrete consist of around 25 to 55%, so we're already substituting of Portland cement for slag cement. Some applications can have up to an 80% substitution rate. So we've talked about recycling, we talked about cement substitution. Now we need to talk about how we actually form our concrete and how we can make that more sustainable. So being more sustainable with concrete installation methods and transportation will inherently make concrete more sustainable. One phase of the installation of concrete that creates waste is the forming phase. So if you're unfamiliar with what forming is essentially making a mold for your concrete so that once it cures or hardens, that's the shape it takes. That's what forming is essentially. So a common material for creating concrete form systems is plywood. A sheet of plywood used from forms may only see one use, however. Think about a piece of plywood, 4x8. That's a lot of wood. If we're only using it once for a big project, that's a lot of wood. So there are many projects that help eliminate unnecessary waste. The first of these projects are medium density overlay, or MDO, and high density overlay, or HDO, plyboards. Both MDO and HDO plyboards are wood products, but where they differ from a traditional sheet of plywood is in their increased rigidity and in the coating that is put on both or one or both sides of the sheet. The coating consists of a resin-impregnated cellulose fiber sheet that is laminated to your plywood board. This coating can allow the sheets to be used anywhere from 25 to 50 times, with extreme care up to 100 times. That's a lot of uses out of one piece of board. While MDO and HDO may be more expensive than traditional OSB sheeting, the amount of uses can be exponentially increased, thus saving money and trees. Heavy-duty steel forms can also be used, however, they are usually heavy and very difficult to work with. So, in conclusion, if you're passionate about the environment and you want to make a change for the better, concrete is a good place to start. Now, in construction, it's one of those industries that's driven by money. So the important thing to remember is sometimes it's better to spend a little bit more money to have something that is a bit more sustainable for the environment. And oftentimes, your client will appreciate that anyway. So with continued concrete recycling, cement substitution, and better forming practices, concrete will no longer be a detriment to our environment, but rather seen as a sustainable building material. Thank you.